All right, here we go. So I'm going to go ahead and share my screen real quick. Get my PowerPoint ready. Uh, okay, can you guys see that okay? Just type in the chat if you can. Just make sure you guys are paying attention as well. Thanks. All right, Sean, thanks. Okay, so today, back to the learning objectives. So we're still talking about measurements. Specifically today, we're going to be talking about volume, mass, and something called density. So we've already kind of talked about volume. You probably have an idea of what mass is, and then you probably haven't really heard the term density, but we'll talk about that. We've already covered length. We've already covered area. That's why I've kind of scratched those out. And I'll cover time and temperature in another video. It's not too long, so it's not won't take a lot of brain power to cover those, hopefully. And then also continuing with the same learning objective of to understand the different instruments and tools we use to take these measurements. Specifically volume and mass, we'll talk about those, and then density again is a little different. So anyways, so volume, just a quick revision of volume. If you guys in your copy, write down your own description of volume, and then I'll have you guys do these sums or multiplications after the video. So real quick, in your copy, write down how you would describe maybe the term volume in science. You can either write it in your copy. Well, you write it in your copy, yeah. And then if you want, you can type it into chat then when you're ready. And I'll move forward once I get a few responses on how you define volume in chat. And for those of you who might be watching this after the live video, you can just kind of skip through these pauses. So you can come off mute if you want to say it, or you can type it into chat. But how do you describe volume? Give you guys 15 more seconds. All right. All right. Anyone have a description of volume? Want to give it a shot? No. Okay, that's fine. We'll just keep moving. So how close were you? The amount of space something takes up. So if I specifically have maybe I have my kind of rectangular, it's very flat, right? But it's not completely flat packet of Post-it notes. Its volume is how much space it's taking up right here, okay? And the way you measure something's volume is kind of what we have here on the right is this diagram. You have to have something's maybe width, how its length from here to here. Oh, hi, Dylan. Welcome. Dylan, we just got started, so we're not too far behind. So you have to find something's length, something's width, and something's height, right? And you multiply those all together, and that's how you find the volume of something or the amount of space an object might take up. That could be anything from maybe these Post-it notes, they have a specific volume, to my mug here of coffee has a volume, right? It takes up a certain amount of space. It holds a certain amount of something. This would be a bit different to find its volume because it's not a square or a cuboid. It's a cylinder, right? And there's a different formula for finding the volumes of a cylinder. Oh, bye, Dylan. But nonetheless, volume is the amount of space something might take up. Okay, so just a quick revision. How close were you? Did you have the right answer? Were you close enough to volume? And then also try to find the volume of the two cuboids on the right. Let's leave that for after the lesson because I don't want to take up a bunch of time right now just doing a bunch of maths, but you will need to know how to find volume, okay? And like I said, if you're looking at these cuboids here on the right of your screen, you just take the height, which here is 10, the length across, which is 12, and maybe the width, which is this back one here, which is 3. You multiply those together. So you can use a calculator, that's fine. Multiplication is a little X symbol, right? Just in case, multiply those together. That'll give you the volume. Same thing here on the right. 25 times 10 times 5, that'll give you the volume. Okay, so that's just a quick revision of volume. This is what we covered on Monday. Mass now. Mass is something newer. We haven't talked about it yet. On the right of your screen here, I have a little scale here, maybe a little potato with a face on it. Mass has to do with, and I don't want to use the word weight here for a specific reason, but it has to do with the amount of particles in an object, okay? So remember, and I just gave this away, remember, what is everything made of? What did we talk about 2 units ago, right? We said that everything is made of matter, right? Everything, anything from the air that I'm breathing right now here to, again, coffee in my cup here. The coffee's made of matter. The cup is made of matter. Everything's made of matter, just different kinds, right? The cup is made of a different kind of matter from the coffee inside, from the air out here, okay? So this is one of the red bullets I need you guys to take down. Mass is a measure of how much matter an object has, okay? Take that down in your copies real quick. Mass is a measure, so it's a measurement, right? You can measure mass. I'll show you how in a second here. Mass is a measure of how much matter an object has, okay? You cannot, and while you guys are taking that down, I'm gonna say a few more things. You cannot use the term weigh for a reason, because weight and mass are 2 different things, okay? But for now, what you need to know is mass is the measure of how much matter an object has, and then as you're taking that down, you can also take down these, you can take down these last 2 bits here. We measure this in kilograms, okay? So that's the unit we use to measure mass in science, is kilograms, right? Not pounds, not stone, kilograms, okay? So make sure you have these 3 red bullets taken down in your copies. If Sean or Hayden, if you want to give me a shout when you finish that up, just a yeah, and I'll move on. Oh, great, thanks. All right, 3 more seconds just in case. Alan or Hayden, great. Okay, all right, so those red bullets are down. Mass is a measure of how much matter an object has, okay? So how do we measure mass? We use this thing on the right called a mass scale or an electronic balance. Both are acceptable answers. Take that down real quick. The tool that we use to measure mass is a mass scale or electronic balance. This is in line with our learning objectives to know what tools we use to take certain measurements, right? So I'm just gonna keep using what's on my desk here. So if I needed to know the mass of my little packet of Post-it notes here, I'd take an electronic balance or a mass scale, stick it on there, and then it'd give me a little readout here. If it's a digital one, it'd give me its mass in hopefully grams. Sometimes these, you can kind of switch the units up a little bit. And I'll show you, I actually have a mass scale here at home I can show you. But yeah, okay. Thank you, Sean. So yeah, easy. How do we measure mass with the mass scale? So the reason I was talking about mass and weight, they're 2 different things, right? And so before I start talking about everything here on the left, I want to take a look at this little graphic here on the right. So you've hopefully seen maybe the video clip of your man Neil Armstrong walking on the moon, right? And he kind of bounces around on the moon because he weighs a little less, right? What you'll talk about in science in the future is why that is, and it has to do with the moon itself being smaller than the Earth, right? So things weigh less on the moon, but they still have the same mass, okay? Since mass is just a measure of how much matter something has, if I move from my chair here on Earth to the moon, to Jupiter, no matter where I go, I'm not losing any particles or matter, right? I mean, maybe I'm losing a little bit if I sweat a little bit or if I eat more food, right? But overall, I'm not really like my arm's not just falling off, right? I'm not losing body parts. I'm not losing anything really. Um, so my mass stays the same since mass is just a measure of how much particles or matter you have. Weight does change because it's dependent on kind of where you are. Okay, so that's where these red terms come in. An object weight can change depending on where it is in space, literally space. So your weight's probably going to stay the same on Earth, but if you move to a different object in space, your weight can change. But an object's mass does not change. And then so we know mass is measured in kilograms, and then weight is measured in N for newtons. Okay, so you kind of need to know kg. This is all kind of just a bit of a. Do we take that? Yes. Sorry, Hayden. Yes, you do. Take these red words down. Yeah. Take these red words down real quick. And then kind of like it says here in the black, you don't need to take this down, but it says in science, we are almost always going to be looking for the mass of an object, not the weight. So in the future, if you're in a lab and I or another teacher asks you to take the mass of an object and you come up to me and say, sir, the weight of this object is, I'm going to say, no, that's wrong. It's not the weight, it's the mass. At least I'm going to do my best. I personally kind of use the words interchangeably, but that's not correct. You're not supposed to do that. You're supposed to say mass, okay? Because then on the junior cert and any other test you take, leaving cert, whatever, they're going to use the term mass. You're going to need to know what they're talking about. Okay, give me a shout when you've got those words taken down there. The reason I have you guys taking these down is because when you get back, you know, we're getting ready for unit tests. You're still going to need to know this stuff. So you can't be having empty copies. You need to have something to look back on when you go to study for example, when we have a unit test on measurements or, you know, your summer exams, whatever, you're going to need something to look back on in your copies. Cool. Thanks, Sean. Give it another second. Cool. Thanks, Hayden. Alan, I hope we're not going too fast. Let me know if I need to slow down or anything, okay? Okay. All right. So now we have this term density, okay? So density, and the reason I'm talking about density is it has something to do with volume and it has something to do with something's mass, okay? And if you look here on the left, notice these two objects, right? We're going to say that, imagine that this kind of cube outline here, right? This purple lines, imagine that's kind of solid, right? And these little green dots in here are the pieces of matter that that object might have, okay? So notice that the one on the left has less matter in it, has less particles than the one on the right. So I can even count the ones on the left. 1, 2, 3, 4, 5, 6, 7, 8. Whereas this other one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It has more than the one on the left, okay? But they're the same size, roughly. They have the same volume, but they probably have a different mass, okay? So what do you think, after I kind of explain this, what do you think the term density means? You can write it down in your copy. What do you think the term density means? Just take a second to even think about it. And then what I want to do here in a second is I'll kind of explain what it means and see how close you are. How much something has in it. How much, so, okay, I get what you're saying, Sean. But so, yeah, okay. But so for example, this coin I have here, I have a 50 piece cent here, 50 cents, right? I can't really fill this up with anything, right? It's not like it's a cup and I can fill it with liquid, right? So how much something, sorry, my doorbell's ringing. um, how much something has in it. Um, you are right in a sense, how much something has in it, but how much of what? So it has to have something in it. How much mass? So correct in a sense, but here, let me just keep moving on. You're getting there. Think about this. So this coin has a certain density. Density is different from mass, right? I can measure the mass of this coin, um, but density tells me more about how much matters on the inside of it compared to its volume, right? So I'll explain what that means in a second here. What is heavier? Answer this in the chat. A pound of feathers or a pound of cement? What is heavier? A pound of feathers or a pound of cement? What do you think? This will make more sense in a second. They're the same. Okay, Sean, why are they the same? Okay, Hayden, why are they the same? You've probably heard this before. They're both a pound. Yeah, exactly, Hayden. Exactly. Well done. So they're both a pound because they're about a pound. Yeah, exactly, Sean. But if you imagine those two, if you imagine a pound of cement, like if you had a pound of cement sitting in front of you, and if you had a pound of feathers sitting in front of you, what would the difference be between those two different piles? Say you had a pile of cement and a pile of feathers that were both equal to a pound. The cement looks heavier. How can you tell if something looks heavier? I don't think you can see weight. I can't just look at something and just say, "Oh, I know that weighs how thick it is." Okay, Hayden, that makes sense. So, for example, I have a little graphic here. 1 pound. It says lead, but you can say cement there. It's the same to me. The pile's probably literally going to be smaller, right? So if you have a pile of cement, it's probably a lot smaller than a pile of a pound of feathers, right? You have to have a lot of feathers to get a pound of them, right? Whereas a cement, you'd probably only need a little bit to get a pound of it. So what density is it's related to a substance mass and volume. If a substance has if that substance, so cement for example, has um, a small volume, you only have a little bit, say maybe my hands here, but a large mass, so a pound at this small, it has a really high density, right? If you have a large volume, so kind of going back to this picture here, if you have a really large volume, so like maybe the pound of feathers takes up an entire desk, right? That's a big volume. It's taking up a lot of space, but you need so much of it just to get a pound, right? That means it has a low density. So density, so take that down. Density is related to a substance mass and volume. So Sean, you were kind of talking about it has to do with how much mass it has, right? But it depends on how much space it takes up as well. And I'll explain how we measure this in a second. If something is really dense, if it's say if you've ever held something that's really small, but it feels really heavy, that probably means it has a really high density. It means it has a lot of matter packed into a small space. Okay? Or if you've ever picked up something that's really big but really light, so maybe it's a big styrofoam ball, and but it's painted black, and it looks like it's a massive steel ball, and you go to pick it up and it's really light, and you kind of like throw yourself back a little bit because it was a lot lighter than you were anticipating. That means it's not very dense. There's not a lot of particles or matter packed into that sphere of styrofoam, right? Okay. So make sure you just have you can have that red taken down there. Don't worry too much about the other black parts. That was just kind of so if a substance has a large volume but small mass, do you think it'd be very, very dense? No, it wouldn't be very dense if it has a really large volume but small mass. On the other hand, a substance with small volume but with a small volume, so it doesn't take up a lot of space, but a large mass, what will its density be? It'll be larger, okay? All right. I'm going to explain this more in a second. Are we doing okay? Have I confused you guys? You feeling okay about it? How are we feeling about it? Looking for feedback in the chat. You don't say anything. I'm just going to assume you're confused and don't want to say it. Okay. All right. I'm going to move on in a second. So I'll give an example. Maybe that'll clear things. I am not confused. Okay, Sean, thanks. That gives me some confidence. And so, but maybe for if you are a little bit, either Hayden or Alan, or for people watching the video now, I think the maths might clear things up a little bit. So from this chart we have on the right here, we can find any substances, and I use that word substance for a reason. We can find any substance's density, right? So I'm sorry, I left my example here. I'll be right back. Let me grab it real quick. Okay, so I have here, put my earphones back in. I have here a packet of custard, right? What I did, as you can kind of see here, we need to find something's density. We need to know its mass, and we need to know its volume. Okay, so to find its volume, pretty easy. I just took the measurements of the base right here, so how wide it is, how long it is, and how high it is. I took those measurements, and they came out to be 5 centimeters. I think it was 5 centimeters here, 10 centimeters here, and 15 centimeters tall. Okay, and then I weighed it, or sorry, I took its mass. See, I do it all the time. I took its mass, found its mass with my little kitchen scale here. I'm not gonna do it now because I already did it. And it's hard to do on my table here. And it came out to be 770 grams. Okay, so we have its mass using the weighing scale or the mass scale. And we can find its volume because I took its measurements. So we take 5 times 5 times 10 times 15 to find its volume. That comes out to be 750 centimeters cubed. That's this little up arrow just means to the power of 3. So like it's that little exponent that makes it smaller. So that's all that means, centimeters cubed, because that's our measurements for volume, right? So to find its density, we then look at this triangle here, or you can even use this down here. We take the mass and we divide it by the volume. Okay, mass, you can always use your calculator. Mass divided by the volume, because what this triangle here is showing you is if you cover up one of them. So say right now we're solving for density, right? So you would cover that up. You can use your hand, but you can't see. Oh, I'm going to cover it up with my hand, and whatever's left, that's the maths that you do, right? So if you have something over something, so mass. So if you have mass over volume, that's what's left over. That means divide if they're on top of one another. Okay, but say you're trying to find the mass of an object and you're given its density and volume, right? If somehow in a question you know the density of my custard, you know the volume of it, but you don't know its mass, and it's asking you to solve for the mass, you cover up the mass, and if what you're trying to solve for are next to one another in your triangle, that means multiply. But anyways, I'm giving you a little cheat sheet down here. So to solve for density, you need to divide mass by volume. We have those in our equation here. 770 divided by 750. So we'll do that real quick. It comes out to be 1.03 grams. So the units for density, it's a little confusing. This is what you'll put after anytime you're solving for density. Grams per centimeter cubed. What that's telling you is that this is how much matter there is per cubed centimeter, okay? So for every cubed centimeter, every bit of volume there is, that's how much matter is in that little space, okay? That's the density of custard, right? 1.03 grams. You'll talk about more density more in maybe second or third year. If you can solve for the density, you don't necessarily have to explain to me what it is. That's good enough for me right now. And also, something else to know, water. I'm going to tell you why water is so important. It says it right here. Water's density is 1. Somebody asks you, what is the density of water? You say 1. So if something has density greater than 1, it sinks, right? If it's less than 1, it floats. So for example, our custard, if I were to stick this into water right now, would it sink or float? Based off of its density that we know right now. Would it sink or float? It would sink. Hayden, Allen, are you in agreement? It would sink. I'm going to take your guys' silence as an agreement. So you're right. Sink. Good job. Thank you. So if something has a density greater than 1, it sinks. We know that custard's density is 1.03, which is greater than 1. Therefore, it would sink. Okay? After this, so this is the red I was talking about. You don't have to take down, try and find the density of an object at home. What I want you to do is do it yourself. So find something that you can either measure. If you try and if you have a mass scale, if you can weigh an object, or for example, this says the mass on it. So food items almost always say the mass on it somewhere. So I know it's mirrored, but it says 750 grams. And you probably have a tape measure at home. Try and find something that you can find the density of, solve it, and then there's a few. I'm going to have you guys sending pictures of your copies to make sure you take down the red words. Include that in your copy. Also, take down this triangle into your copy. And you can take down the little box down here as well, just to help you understand what's going on. So take down those. Take down that triangle real quick. Don't worry about finding the density of something right now, obviously. Take down the triangle real quick. Okay? You're going to see these triangles a lot in science. All right, great. Thanks, Sean. Wasn't sure if you guys had seen that yet. You'll see these triangles a lot in science. So they'll make more and more sense over the next few years. But anytime you see a triangle like this split up into 3 parts, if you always cover up what you're trying to solve for or find. So if the question asks you to find something's density, cover it up. And then if they're over one another, that means divide. If they're next to one another, it means multiply. Okay? Okay. What I have here, I have this sitting here, and you've probably seen this before, it's really hard to see. But what I have is oil and water, right? Based off of what you see here, and probably what you know, let's see if I'm actually gonna, there we go, that's better. So what do you see here? Describe to me what you see in this jar. There's oil and water. The oil is floating. Correct, yeah. So Sean says the oil is floating. It's on top of the water. So what do we know then about oil's density? Is it more or less than water? It's less than 1. Very good. Very good. So we know that oil's density is less than 1. It's less than water, right? So if I were then to take this 50-cent piece coin, right, and drop it into here, we see there it's at the bottom, right? So what does that say about the coin's density then? It's more than 1. Very good. That's all. That's the little bit of density that we need to know right now, okay? So we know that density is kind of explaining how much matter there is in an object compared to its volume, okay? Um, so if something has a really high density, you can have such a small little bit, but it might still have a really big mass because it has a lot of matter in it. You Matter is so small you can't see it, right? So you can keep packing matter into an object, a specific substance, you would never know, not necessarily. So if something has a lot of matter in it, and has a lot of matter in it for such a small space, that means it has a high density, and vice versa. Okay, that's all I have for you guys today. So make sure that you guys have those red lines taken down, and then I'm going to upload here in a few minutes another Google Forms just to kind of gauge your guys' engagement so far. And then that's it for the next few weeks, because next week is midterm. So if you have any questions about anything, let me know. Hopefully you guys got all that, and I'll see you guys soon. Okay, that ends today. I will see you guys soon. Bye.